All right. Hey, everyone. This is Eugene, and today we are with Matt and James, and we are going to discuss Berry.cards today that I built over the weekend, starting on Hack It Friday. And let me present my browser. All right, so this is the Berry.cards home screen, and idea is this is somewhat like a hot or not for Berry Club historical boards. And when you log in, you have a option to vote between two pictures, and when you pick one, it loads the next vote, and so on. Then you have an ability to buy a card. So let's say I like this card, I can preview and see that this card is new because it's only 1 year. I can buy it, and the price of this card breaks down into 99% goes to account that I called Art DAO, and 1% commission goes to the app. And it is saying that the new price is going to be 20% higher. So when you buy it, it goes to the wallet, and you approve a transaction that goes to this contract, which is Cardsberry Club ek.near, and it will attach 1 year there. Once you approve the transaction, it's executed on chain, and now you own this card. So in home, you can see your recent votes that are stored in local storage, and you can see the price of each card on which you voted for. So the way it works, it's not like a real NFT where you actually own it and no one can take it from you, but instead cards are always on sale. The price is dynamically determined based on the votes. And there's also a global leaderboard of all cards that are for sale, ordered by price. So the first are the most expensive, and then they go down in price. So there's more of them.
Can you explain the vote mechanism just while we're talking about ordering by price?
Right. So the way vote works is you presented two options from the contract. So the first option is, well, the contract based on the block randomness and from chain, it generates a request for you. So you cannot like select one of your cards and vote on it. It's generated on a contract side and later like retrieved by a frontend. So you given two cards. One of these cards may be like each of these cards can be either a random card from one of the historical blocks, like we saw with this card on that I just purchased, or it can be one of the existing cards that someone already voted on. So it can come from the leaderboard. Then when you select a card, that card is considered the winner and the other one is a loser. And the winning card, it gets the 10% from the price of the losing card. So let's say this card was like 5 near, this card was, the right card was 3 near. So the winning card will get 0.3 near from the losing card, and the losing card will lose 0.3 near in price after this vote. Plus, every winning card also get 1 bonus near. So this is how initially the price get priced at 1 year. So
this is like an NFTCR.
Yeah.
Essentially, it's a TCR based off of NFTs.
Right. So then when you make a purchase, So let's say this card is owned by Vlad, and you can see the price at which Vlad bought it. This is recorded on a contract. Then you can see some statistics for this card as well. So the total volume and how much went to the DAO account. Now the price was actually changed by a number of votes on this card. So Vlad will make a good profit if you buy it. And then 10% will go to DAO. So initially, when the card is not owned by anyone, 99% goes to DAO, to Art DAO. And if card is owned by someone, then 10% goes to DAO, 1% is commission, 89% goes to the owner. But when you buy it, the price also increases by 20%. So it automatically boosts the price, and it will be in 9 years. So in case someone buys from you immediately, you're actually making a profit. Now, there are some interesting tricks that I used to make it run faster, and we will probably talk about this later when we look at the code. But one interesting part you can see is when you vote, you immediately present it with the next option, like almost instantaneously. While the actual voting takes at least 2 blocks, because you need to issue a transaction from your account that goes to the contract, and later it also gives you some gas refund. So that takes at least 2 seconds in the best case scenario, and 3 seconds in when you like very late for the current block. So in order for you to be able to actually vote faster, there's a multiple request that's generated for your account. So it's not one request, and then when you vote, you get the next request. Wait for the next request. Instead, we keep 3 requests for your account already generated. When you vote on the first one, we will generate a new one at the end of the queue. So the front end actually has a queue of the request. Now there is also your profile, so you can see statistics of your account and cards owned by this account. So this is very good if you want to, for example, to steal some cards from Matt Lock. But Matt doesn't actually have any cards.
I got liquidated last night.
so yeah, you got some nice profit going on. So we can. I also know CPU Near. He's like very big on the Berry Club, and he usually has some good cards. So we can like go to his account and like check out some of the cards and like just get like some good stuff from them, and then you can make a nice profit of this by sniping like good cards early on. So, and right now the leaderboard is not displaying the tail, so it only displays the header. Oh no, the transaction failed. Let's try again. Actually, it did work, just front end didn't update. So anyway, that's the front end, and that's how it works. So it also keeps tracks of statistics on the front end. So you can, on the contract, so you don't need to go to Indexer to figure out certain stats. That's somewhat more expensive on the gas, but not as bad. So this is a global statistics on overall contract, and there's 1,000 votes. So I actually launched it yesterday in the evening.
What time?
Pacific.
What time?
It's like something like 6 p.m., 5 p.m. Pacific. So it's less than 24 hours.
About 16 hours total only.
Right.
Wow.
And the total volume was 2,700 near. The Art DAO account actually got 500 near, and I plan to donate all of this proceeds to CreateBase DAO account so they can onboard more people. And it actually generated me 27 year of commission that mostly covers my contract costs, which was 14 year, like 13 year, and plus some storage that needed. And
Let's.
you can,
I just want to give people who might be watching the recording later some background on the CreateBase community. So they're going to use all of these funds to onboard new users, artists, etc., into other apps like on Near, like Mintbase, etc., etc., etc. So that's where the proceeds are going, basically, to basically pay and fund new artists joining Near.
so the only like thing for me is to figure out how to actually where to transfer it. I know there's a on Sputnik DAO there's a CreateBase account, but I'm not sure if it's the latest. So I need to figure out where to transfer it, and later I can update the contract to actually directly fund this account instead of going through this account. Cool. So this was a front end.
Eugene, I have another technical question about
Yeah.
how the cards are plucked out of the historical cards from Berry Club. And for people who don't know, Berry Club is basically a sort of a draw by pixel $1 million homepage kind of app that was also made by Eugene a few months ago.
Show the
right?
Berry Club.
Yeah. And then you can explain to us how, because some of the cards are like perfectly chosen, like with Mario and like
Right.
a bunch of characters. So I'm just curious how they're like chosen out of Berry Club.
Right. So right now all these cards are chosen completely randomly, and then people who were voting on them actually pick them out of the random pool and then price them based on like this 20% boost in the pricing.
So there's no other, just to be clear, there's like no other mechanism or like thing running in the background that is specifically saying, okay, take Berry Club at this particular snapshot and show it in the voting.
No.
Okay.
No. So
Really
for example,
cool.
this card.
And
If you
it worked.
yeah, if you open this card, it basically goes to a tool that Vlad Gurchina built called Wayback, and it allows you to check either individual images or accounts. So you can see the history of drawing of a given account. And right now it's a block 27494989 on a mainnet that contain this particular state in the Berry Club. And then people bet on this card. So this card alone generated about like 500 near in volume, and got like pretty high revenue for Art DAO. So my idea originally was to distribute this to the artists who draw this card. But it's very complicated to do because there's a ton of noise, and that was the mechanic of Berry Club, where you can just draw on top of the other people art with like semi-transparent pixels, and that will like may consider you as the owner of the art. But so it's a human job to figure out who's the artist and maybe reward them. I actually know who the artist is, but maybe we'll build tools to actually display. So you can hover over pixels to highlight who the artist is. Similar how on Berry Club you can highlight pixels of like who draw what. So similar to this, we can potentially build a tool that takes a historical rendering and on the right displays a leaderboard, and the human can actually decide who should be receiving proceeds for this card. But this may be a slightly different project and out of scope of this meeting today. So let's actually jump to the code. I think I'll stop presenting this and let me present my C line. Cool. All right. So the contract is written in Rust using a near SDK, and it uses a breakdown into different modules. So we usually start with TOML. So this one uses a version of SDK 3.0 that is not fully published yet. There are still some changes that we want to do. And let's actually go through a main library. So it uses Panic on default, and it initialized the app by giving app owner ID and Art DAO ID. And instead of storing them in a main structure, as we usually do, like we usually store all data related to the contract that is global into one structure. This app uses a new trick that groups certain data into a separate structure that I call trade data. Because when you vote on a contract, you don't actually need to touch data related to trading. So in this case, you don't need to deserialize this data from common structure, and that saves you some gas. So the trade data is not as large as it would be, but it's still a bunch of fields that is not needed for most common operation, which is voting on something or like querying the rating. So, and now if you go back to the initialization, you can see I have a method called save trade data. And what it does, it actually takes the trade data, serializes it to Borscht, and stores it under trade data key. So it's similar how an ordered map stores some field into the persistent storage. And unless you need this field, you do not serialize this. So here you have load trade data that reads this key and pulls it out of the storage. So it's kind of nice. So when you need the trade data, you deserialize it. And then the only thing you don't need to forget is to save it back when you actually modified it. So the contract state is automatically saved at the mute once the method completes. For trade data, you need to manually call save trade data when you actually modified it. So the first thing we will look is to accounts. So when you start an app, you first check if you already have an account, and if you don't have an account, then it registers an account for you, which returns you an account. So this app doesn't implement storage management because it takes a commission, and this commission will likely cover, right now at least it got 27 years, so it covers the storage fees for the user. So I don't need to, like users don't need to worry about separate storage management. So it follows the pattern of Berry.cards where the app just covers the storage cost for onboarding users. So we create an account. An account has the following. It has a vector of request, which is not a persistent vector. This request is like request for votes. So each request is a left card and a right card. So this is how what you see when you're trying to vote on it. Then you have a list of cards that, a set of cards that you own by ID. So that's how we know which cards you own per account to display it. And then some statistics such as like what was your purchase volume, what's the number of purchases you made, what's the profit you made, how many sales, how many votes you did. Then I have a separate structure called account view. which is implements third serialize, and it converts to a JSON-friendly type such as wrapped balance, and removes this cards structure from it. So you don't provide all cards at once, and you need to separately query them, but instead it gives you a number of cards per account. And here's a bunch of view methods, such as you can get all accounts, which I don't currently do. And you can basically, I don't have this this page on the app that will display who account owners right now. And then you can request cards from account also using pagination. So both of them support pagination. If there's like thousands of accounts, then let's say a limit that it can handle is 50. So you would just request a bunch of pages either at once in parallel or like the way you want, one by one. And there's two inner methods, one that creates a new account, and that question that pops up frequently, like if you have inner persistent collection, then what is the prefix of the inner collection you should use? And this prefix has to be unique. And for this, I'm using the hash of the account with the prefix U. So this prefix is unique across entire app or entire contract. And this prefix is unique per account. And this way I initialize the set. This is the number of cards per account. And save account just stores it. So this is an account. Now, once you get an account in the app, you actually can see a method. It also generates you requests to vote. So it will generate you 3 requests. And the way we do requests is we take a random seed from the state. So the random seed is queried from the chain, and then we generate 3 requests for you in a loop. And this is a Rust way to write a functional loop, but it's the same as like for loop that pushes into the vector. So first thing random request does is hashes the seed. That actually a trick to continuously get more randomness because the hash is unpredictable from the seed. So then we split it into 2 U128 values and generate 2 random cards. And if for some reason the cards are generated the same, we will continue to generate a new set. So, and a random card does the following. If a high bit, which is 64-bit, not the highest bit, but like one of the high bits, is positive, then it means we're gonna use one of the existing cards. So we look if we already have at least 10 votes, then we will randomly choose a card based on a random value. So we basically pick one of the cards that was already voted on. Otherwise, we randomly pick a new card from a current block minus the total, the first block when the Berry Club actually had an empty screen and return this block height. So card ID is just a block height on the mainnet. And this was needed for testnet because testnet block index is different from mainnet block index, but we still use mainnet. So for running this on a testnet, I had to hard code the mainnet last block. So this is how you get an option on what to vote. So you get a left card and a right card generated for you on a contract side and returned to you on the front end. Now you display this card, 2 cards, and you want to vote on one of them. So you pass your request on what you're voting on, and the response, which is you selected left card or the right card, or you skipped both. So sometimes you want to skip both. In this case, they are not affected, and you just skip in this request. So we get your predecessor, we get your account ID, and we verify that your request that you're voting on, the first request, is matching the request that you passed. In theory, you don't really need to pass the request, and we can like assume you're voting on the first. But if there's some delay or front-end issue and you don't want to like actually cast a vote on an unexpected request. So this sometimes happens when there are like some issues on the front end, potentially like the first was declined and the second issued, and we just don't want you to vote on incorrect requests. So we remove it, we add a new request that we generate for you. Then we resolve the request. So resolve request actually updates the ratings of the request, the pricing. Then we increase the number of votes you did, and we save your account and get you the last request, that the new request that was generated back to the front end, so it can add it to the queue without querying the account ID again. So how we resolve the vote? So you get the request, and for some reason it's called old request, and the response. So response, if you selected left card, we say go left, we want the right. If you selected right, then the right want the left. So how that works? So you have 2 cards. So the winner card and a loser card. You get the rating, which is the price of the winning card. Now we have a tree map. So this is the new thing that I don't think we reviewed in the past. So I probably should give some background. What is a tree map? So the tree map is a collection, a persistent collection that implements AVL tree, which does most operations in O1 or log n time. In the worst case scenario, it's insert and remove is log n, where n is the number of elements in the collection. So for 100 elements, log is 7. So for full rebalancing, it may be like 14 touches. So it's fairly expensive, but at the same time, when it's large, such as like thousands of elements, it only increases to like 20 touches. So logarithmic scale gives you ability to operate on thousands of elements, like even millions of elements in this collection, and only spend like relatively low amount of gas. So you may fit into a limit of the transaction, even so it gets expensive on every operation. Now,
And it self-balances, right?
Yeah. Now, what is the weird setup I have here? So tree map, what's up?
Would it rebalance when you insert or remove an element, like basically a certain user will end up paying for that rebalance, and
Yeah.
there's no good way to predict who that will be.
Correct. Well, it does rebalance when the height becomes large, then it might trigger. So I had these issues before. Where the gas cost goes to like 90 TR gas for a call to like vote. So it's possible that we'll eventually hit the limit on the gas, and I'll need to bump the gas per vote again to like something like 150 on the front end.
Is the sorting important? Why not use just a unordered map?
Yeah, so for this tree map, I actually need the sorting. This is the leaderboard of the cards, so they need to be sorted by price.
Oh, so it could be like in a heap.
No, because heap doesn't support deletion nicely. So I need to delete the old element and reinsert the new element.
That's true.
So the way it works, I'm using tree set. We don't have tree set. So I'm using an empty element for the value and a key, which is a rating or the price and the ID. So this is a common trick, how you implement a sorted collection with the lookups. And you have a duplicate inverse map, which is the card ID to the rating. This is needed because you want to know, so you have a card ID, you need to get the current rating, then do some operation on this rating and put it back. So the way you do this is you get the card ID, you get the rating, you delete it from delete the old rating from the map, then you insert a new rating into the map and update this. So for example, like Dijkstra on a map implements this way. So like you can pull and update. So that's why a key is a composed pair. So the first is the price, the second is the index to first identify it, and the second is to, so you cannot put a card ID as a value because if there's two elements with the same price, the card ID breaks them into two different keys. Okay, let's go back to.
Can I ask a more meta question about this before we move on? It's okay.
Sure.
I'm wondering, like, this feels like what I imagine the fancy tricks people had to do before relational databases existed. And then like relational databases gave people a really nice abstraction that was easier for the average engineer to think about without needing to like do this kind of complex data management stuff on their own. And without needing to know how they're going to use all their data ahead of time, of course. So do you imagine that someday we could create some kind of more a layer of abstraction between what contract engineers like need to write and these kinds of, could these kinds of things become implementation details of that layer? Or do you think for the foreseeable future, contract engineers are always going to need to learn these sorts of tricks?
No, I think you're right. But at the same time, we need to do extra work to decrease the cost of this map. Like right now, it's too high to just like abstract it. So what it does is indexer, or like it creates an index on the secondary key, which is like you have two indexes. You have index on the card ID and you have reverse index on, well, in this case, direct index on the price. So when you create an index for card ID, it's only lookup index, so it's a hash index. For a price, you need ordered index. So yeah, it would be like a macro that you would abstract, say, So if we re-engineer our contract to be something like a database, and you define an entry in this database, like you define a table and you define entries, and then you can say, I want this to be my primary key with only lookup functionality, and I want this key to be order key with this functional. Then yeah, this stuff will be much easier. You just say, I want to update this entry to this entry, and that will do the trick. So it will do the removal and reinsert. And
So does that feel achievable today, or does it feel like we'd be building to a specific use case and leaving out a lot of other potential? Like, does it feel like that abstraction layer could be built now? We already have enough knowledge to do it, or is there more groundwork that needs to be laid?
Yeah, I think I think we definitely should rethink our contracts and the way they work. Like for example, like this is the first step. I introduced this trade data. It's because I don't need this data every time. I don't need to read all the fields from my contract until I need them. So I don't need to bundle them together into one field. So I would prefer if our like contract would be not like this, but maybe like if you would think about how you actually want to do this, then you have cards, and then you have table, like card table, and then you have maybe account table, and then you have like some global variables. Maybe like you have stats, which would be stats table, or stat object. And then card table can be something like, as we talked about, you have pub card ID, and then you have card ID, and you mark it as like, oh, this is a primary hash key, or like just hash key. Or maybe you mark it as a primary hash key. And then you have rating, which is U128, and you mark it as index sorted key. Something like this.
I like that.
And this you mark as a table. And then some macro work behind the scenes figures out now it will not be reading this table directly if you don't need to, but it will be like creating something like a field cards on your state, or like field 0 if you want to, and this will be like field 1 in a storage. So it will not deserialize all this data immediately unless you dereference it first. So like, unless you need to access stats, it's not gonna read it from storage. So right now, bulk reads are much cheaper than independent reads, but once we fix storage access cost, individual reads will be as cheap as bulk reads. That will bring that functionality better into the play. Another idea there is to change our APIs. So for example, right now, when you read data, so let's say you did value, you do storage read, this for example, A. So behind the scenes, it actually reads the value into the vector and copies into local memory. But you may not want to do this. Instead, maybe you just want to like, oh, I want to return this value. All right. If you look at the deep level API and look what storage read does, it reads this into a register that it's called atomic op register, but it's just a register number. So when you read a value, it doesn't have to read it into the WASM memory. It can just keep it in a register until you need to dereference it. So when you return a value, it needs to return this register back. So it would avoid extracting this value out of VM into your WASM memory and writing it back to the value. It's not going to work for certain things like serialization, but maybe eventually we'll get rid of this as well. So we have a lot of things to optimize on the Rust side to make compute cheaper. Like you don't need to deserialize immediately. You don't need to serialize, or not deserialize, but read immediately from register only when you need it and stuff like this. So we can have a lot of performance gains, plus like redesigning these collections into something like tables. Okay, so we're a little sidetracked on this. What going on? Cool. So the way this method updates value is, as I explained, we pull it out of the rating. Then if the rating was above one near, or at least one near, then we remove it from leaderboard. So our leaderboard only stores cards that are above one near. This is just an optimization that like cards that falls out of leaderboard are not stored there, so the tree map doesn't grow as fast. Then we split the loser rating by 10, and this is how much we transfer to the winning card, and decreasing the loser bet, it cannot underflow because it's part of the loser rating. Now we increase the number of votes we did, we increase the rating, we insert the winning rating. It's always going to be above 1 year because of win bonus give it. Then if a loser rating is more than 0, we will store this card, which is in a rating table. We always store positive. In the sorted table, we only store when it's above or at least 1 year. Okay, so this is how a voting updates the rating in a map. One thing probably interesting is how we retrieve the leaderboard. So it also has pagination, even so frontend doesn't use it right now. And the way it works is you can pass from key and a limit, and it creates reverse iterator from this key, and try to take a bunch of elements and then convert them to JSON readable values, and then creates a vector. So and then you can use this value and pass it back if you want to continue pagination from a given card. So I haven't done it on the front end, but it's possible to have a infinite scroll, well, not infinite, but full scroll for the leaderboard for this cover page. Now, finally, we need to look into trade. So trade has a collection of purchase information per card and a bunch of stats, global stats. And the biggest function is buy card, like the largest in size. And the way it works is you say which card you want to buy and you attach enough deposit to cover the purchase. So we get the current price, and if there's no current price, then we say the card is not active, which means you cannot buy a card on a block that was not randomly selected. So you need to first discover this card, either by voting or find it when someone else voted on this. And for this, it has to be selected, so it can be a random card. Then we see what's the price you want to buy it with. And if it's lower, then we say you cannot buy it. So that might happen when you actually try to buy a card and someone else voted on this and the price has changed. Now 10% goes to Art DAO, 1% goes to the commission of the app, and the owner gets the rest. We load the trade data at this moment from reading a key. We create a purchase information, a new purchase information. Then we check if there was a previous owner. And if there was a previous owner, we get their account. We remove this card from their possession. We log that we're saying, hey, we're going to pay the previous owner so much near as a log. Then we update the purchase information based on their information. So we increase the card volume, we increase the profit and number of trades on this card. We say that this account sold the card. So this is seller account. And we give them their profit and we save their account and we return them some profit that they made on sale of this card. Now, if the account was not there, so no one owned this card before, we say, oh, this is a new unique card that was just bought. Entire profit goes to Art DAO and the purchase updates it. It also gets the profit. Now we insert the new purchase information for this card. We update the total volume of near. We increase the profit of the DAO. In statistics, we update the commission of the app. We say there was one extra purchase. We save the trade data. Now we say, oh, the money goes so much near goes to Art DAO, and we say, who's the Art DAO? And we transfer the profit. Finally, we set the new rating, the new price to be 120% of the previous one. We update the setting from the previous price to the new price in an optimized way. And now we need to update the buyer account. We add a new card. We say the purchase amount, number of purchase volume, and we save this account and we return this info. That's a lot of the statistics updated within the contract, which potentially should be handled by indexer and don't need to be like computed in the app because the contract doesn't really act on this information. So if the contract would say like, okay, once we hit 10K volume, this is when something happens. Like let's say commission decreases. Then we need this info. For now, we do this only for statistics. It probably burns extra gas that is not needed to be burned, and stuff like this. Similar how currently we don't use leaderboard in a contract for making decisions, but we can. And what else is interesting? I think we looked at all files. We got rating, library, cards. Yeah, I think we covered everything on the contract side. So it may be helpful to look at the application, but probably it was to doing it at different time. There are some interesting tricks on the application side that I'm using that may be helpful for other people, developers. So application is here, and it uses a bunch of React stuff. And one thing I do for this app and also near FM is caching of the data. So for example, I cache the account queries. So you don't need to requery the account if you already did this. And it uses this kind of weird trick of like, if account is already fetched, then we return the promise. If not, then we return the promise and remember it. And then within the account, there's my laziness to implement card fetching as well, with a similar fashion where you fetch cards of the account and remember it. So if two components query this data in the same time, they will not issue two requests in parallel, but instead will wait on one request. And this is how I do pagination. So you know the total number of cards, and you can just create multiple promises first with different offset, and then you do promise all flat to fetch them all in once in parallel through RPC. So that's like a very fast way of fetching like a ton of data.
Are you accepting pull requests?
Yeah, you can do a pull request.
I just see some front end stuff that I would want to clean up, but the
Cool.
promise.all stuff is great. I mean, obviously the general approach will stay there. Just tighten up the code a little, make it more JavaScripty.
Cool. Okay, let's have a few more questions and then we can close this. All right, if there's no more question, I'll stop sharing. And thanks everyone for listening. And then, yeah, Mike saying U64. So for U64, actually, for a lot of places, I don't need U64 because they are smaller than like 32 most of the time, but we for some reason store it as U64 anyway. So I'm using it for timestamps, and I think that's it. For the rest, I use just regularly returning the value. Okay, thanks everyone. Bye.